Good afternoon. I was asked by Amica to participate in this event, so I'm happy to be here to talk a little bit about the energy transition in Canada and Ontario. Let me briefly introduce you to WISE in case you are not familiar with it. WISE is focused in different aspects of energy, sustainable energy within the University of Waterloo. It's an institute that basically gathers a series of, a group of researchers. We don't do, as an institute, we don't do research, but we facilitate research within the university. And we cover all different aspects of energy, conservation, power systems, power grids, hydrogen, you name it. We cover all of these aspects of delivery, policy, technical aspects of associated with sustainable energy. Now, as I mentioned, we have about 130 members. We have coming from different faculties, and there are students associated with them. And we basically, they also run these multiple labs, which are 30 state their facilities, hoping we can add a new one, a new facility soon to this group, a microgrid, for researching different aspects of basically the access to energy, because we are also looking at those aspects, as I will mention. We have a professional team that basically takes care of these, enabling these collaborations and facilitating this research, or making these contacts between industry, researchers, faculty members, etc., to make facilitate this research working within the University of Waterloo. Now, we have a global outlook in the sense that we don't only look around us in Canada or Ontario, but we looked at the rest of the world, and we have collaborations with multiple entities, multiple institutions in Canada and abroad. And we also have we're part of the Waterloo culture of innovation, in the sense that we not only look at the issues of research, but also commercialization aspects of it. So we are embedded within that context of within that culture of innovation in Waterloo. Now, we also have, which is run by Amica, we also have the Affordable Energy for Humanity initiative. So we have collaborations in all these different countries that are highlighted here in the map, which we collaborate in different forms, which are basically listed here. So we have all these global partnerships. We have 150 members from multiple countries. So this is one important part of WISE is this initiative, which is looking at issues of access to energy, which includes academia, companies, communities as well, which is very important in these aspects of access to energy, and multiple partnerships. Now, we also, Ambic in particular, runs all these student internships. We have some grants that are supporting these initiatives, which are basically co-op internships for UW students to go to these different places that I highlighted in the previous slide. Now, many of these students then go on and continue their careers in sustainable energy. So I think we're doing some good by engaging these students and making them basically aware of what is going on in this area, and also engaging in different aspects of sustainable energy. But most of this work is particularly focused, as I mentioned, on access to energy. So they go to small communities in Africa and India, in which they basically collaborate with either already communities or institutions or companies that are working in this area. So we also work, or Ambic in particular works in this different aspects: sustainable development, sustainable development education. So that we organize multiple campus events, classroom presentations, lectures, capstones project, which Ambica is leading a few, and we also have these innovation labs that in which basically we have these members of the initiative, of this organization, because technically it's an organization, in which they basically meet for about a day, in which basically there are interactions between all these different researchers who are participating in these events, and there's one coming up in April in Spain, right? And there's another one in this. The student one here in Waterloo, and we're planning one in Waterloo for next year. That will be funding and organizing here. And we've had previous ones. I participated in a couple of them. One in Waterloo, and one in Germany, I remember, with our collaborations with KIT, Karlsruhe Institute of Technology. Now, this is the group. I guess you have met them already. We have Armugan, we have Sana, we have Ambika, and myself, which I'm the executive director of the program. Now, just to give you an idea of the work we do, because all of the work I'm going to be describing here is associated with power engineering, and I'll explain why. We're particularly well positioned within Canada and the world as having a very significant or very important, very relevant power group in Canada. We cover very different aspects in the world, in fact. In North America, we are one of the top programs in power engineering, and we cover all different aspects of power engineering, power systems, distribution systems. So we will look at high voltage, medium voltage, and low voltage networks. Electricity markets, we have cover high voltage, which is quite unique in terms of what is happening in the context of academia in North America. Very few high voltage labs have remained, and we have one that's very active. Power electronics, protections, which is relatively new for us, and all of us work in different aspects of smart grids, intelligent loads, ADNs, electric vehicles, microgrids, etc. We are very well known within the context of power engineering with multiple IEEE fellows. We have unique research facilities. We're hoping to add a new one to the facilities we have available. Many good students and multiple collaborations, national and international. In my group, in particular, I work in different aspects of power engineering, smart grids, from the point of view of the residential controls, energy management systems for houses and buildings. We have created a series of when we're part of a project, we had pilots that deployed in multiple houses for energy management in homes. We actually did some pioneering work in that area, and developed some work and patents in that particular realm. And we have also worked at the distribution system side. Now, my group also works renewable energy sources, or the integration of wind and solar, from the point of view of modeling, stability control, and also planning. And we have worked quite significantly in electric vehicles from different aspects of electric vehicles, not itself in the electric vehicles itself, but in their interaction or the interface with the grid. Okay? So we have worked in the smart chargers, smart charging applications, the impact on distribution systems and transmission systems. Flexible AC transmission, in which we have developed some models and controls, and we have developed a new device for interconnection of microgrids based on these principles. Energy storage, have done quite a significant work in all of these different energy storage technologies applied to power systems, and particularly from the perspective of how they interact with the grid and how they work with the grid. And finally, microgrids, in which we have done quite a bit of work for the last over a decade in different aspects of control, modeling, simulation, stability, but particularly from the point of view of remote microgrids, because there's a particular need of that in the context of Canada, northern Canada. Now, with that said, let me get now to the topic that I wanted to discuss today, which is how we see the energy transition from the perspective of the Canadian situation, and also in particularly Ontario. Now, I'll give you a bit of motivation of what is driving all of these, particularly from the electrical system point of view, because it's one of the backbones for the energy transition, for net zero, will be electricity. I'll give you then an overview of what the situation of the Canadian electrical grids or the electrical grids in Canada, and how they look from different perspectives, particularly with the potential of becoming net zero, okay, by 2030, which is what the government of Canada has stated. Including remote communities, because it's a very important part, as I mentioned already, of the energy systems in Canada. It's somewhat unique with respect to other countries because of our particular geography and particular political and social situation. Then I'll cover Ontario. I'll get into the details of Ontario from the point of view of the grid, the market, and what the grid is supposed to look like in the future. And finally, we'll discuss different aspects of the energy transitions, electric vehicles, the plans for net zero, the hydrogen strategy that Canada has, and some conclusions of all these aspects that I'm going to be highlighting here. So first of all, what is motivating all these changes or this transition is the issue of climate change, right? So we're all dealing with those problems, which is generated by fossil fuels and emissions of greenhouse gas emissions, right? Across it is across the world. So it's not only a particular problem of one location in the world. Now, to basically eliminate emissions, one important part of this is going to be electricity. So there's a drive for the electrification of everything, right? So everything is going to be driven by electricity. I'm talking about electric vehicles, fuel cell vehicles, because the hydrogen is going to be green hydrogen driven by electricity. And in addition to that, thermal systems. So we're talking about heat pumps, ground source heat pumps, ground source systems that will allow this transition to occur. Okay? So the backbone of this transition is going to be electrification, which needs to be basically clean energy. So we need to replace fossil fuels now in the generation system, because fine, we use electricity to, for example, eliminate emissions from electric vehicles. However, that energy has to be clean. Okay? And then we're talking about cleaning the electrical system, right? And basically replacing fuel-based generation, which are emitters, with clean sources. Right? We're talking about wind, solar in particular, and also energy storage. Now, keep in mind that none of these, there's no free lunch. So however you produce electricity, you also you have losses and you have the possibility of emissions. So even in the production of these, the role of emissions have to be considered, right? For example, there's a lot of plastics involved in all of this, right? So that is an issue in terms of where do you obtain the plastic and where is that, those chemicals are going to come from. Hydrogen is another very good example of it. Hydrogen is used throughout many industrial applications, not only for the purpose of cleaning the electrical system, but also from the perspective of how this is used, for example, in steel production, in cement production. So that's an issue that has to be addressed, right? Now, the problem with all of these, of the electrification, is that you're going to have to basically increase the generation pool and also the generator plants and also the transmission system, distribution system. So there's going to be a significant increase in the size of the system, the electrical system that is going to be supporting all of that. And one good example of this is the electric vehicles, right? For example, when you're talking about electric vehicles, for example, my vehicle, it's a CORA EV, Hyundai, it gives me about 400 kilometers and has a 10 kilowatt power maximum load. So when I charge, although it doesn't exceed 7 kilowatts, I'm basically doubling the charge of my house. When I'll discuss electric vehicles, you'll see that particular impact. So basically, you're doubling the load of the house, right? So we have to be very smart about how we're going to be, producing electricity for that vehicle, and how we're going to be charging it to have a minimum impact on the systems. Okay? And so there's going to be a very significant impact on demand. So a very important part of this transition is demand side management and demand response programs. Okay? In the sense that we're going to not only look at the generation, but also we're going to have to look at the demand. It's a very important part of all of these cleaning of the system, facilitating or making possible that there's this transition. Okay? Now, and another very important part is all the development of energy generation is not only at the big plants, but also locally. Solar panels, like the example we have in this building, right? Your homes, at basically small locations, distributed energy resources, okay? Which are actually facilitate the integration of all of these renewables into the grid and reduce the demand, keeps the demand or the generation local for the local demand, so you don't have to have more transmission to transmit power from big plants. Okay, so there's all of these interplay with all of these different aspects that have to be considered in this sort of electrification work. Okay, now what are the status of all these systems? What is the situation nowadays of the electrical system? So let me give you a bit of an overview on how this is going to impact or facilitate or allow this transition. So when we look at an electrical system, we have a particularly clean system. So if you look at British Columbia, which doesn't have a competitive market, so it's basically a standard vertically integrated utility from generation, transmission, distribution, okay, the good old Ontario Hydro, okay. So they basically, most of the electricity, as you can see here, 90% of that is hydro, okay. They have a little bit of natural gas, which is not very significant, as you can see here, 2%, so it's very small. Eventually, that's going to have to go away. But other than all the renewables, you don't see fuel here. Pardon me, wind and solar playing a particular role. This is changing because there are issues with water supply. Okay? So, for example, what is happening in Quebec is that because of all these issues of lack of water, they are trying to integrate wind into the already clean system. Okay? To use wind instead of using the water resources, which are becoming scarce. For example, one of the main problems that France is dealing with all these nuclear stations is that they require water. And they have a big drought in this past summer. They had a serious problem trying to get the water required for those plants, right? So that's an issue that has to be dealt with. And Quebec is starting to face that problem. Although in Canada we're blessed, we have incredible resources in terms of water, right? So we are particularly well placed. However, there's a concern about how you manage this water and whether you can keep building dams and hydro stations, okay? Because they also have other impacts on the environment. So this is a very clean system. So the issue is how to get rid of the little gas and oil that is still being used in the system, which, as you can see, can be very small. It's very small in the case of British Columbia. So 2030 net zero, from the electrical point of view, quite feasible. Okay, no problem. However, now this is not working. Okay, it's working now. Thank you. Now we have Alberta. Alberta is exactly at the opposite side of the energy problems that we have in terms of the grid. And as you can see, 90% of it is coming from natural gas and oil byproducts. So it's exactly the opposite, right, to British Columbia. We are just a province away. And the issue that they are facing because of the way the system developed, I guess they could have developed a hydro-based system. They didn't. They have water resources in the north, but the system developed based around the oil business, right? Which made sense at that time. However, they have a major problem. How are we going to transform all this system into a clean system is a major challenge. And in that context, nuclear is going to have to play a role. Interconnections with other provinces is going to play a role, particularly British Columbia, but they have a political fight there. So that's another another problem with Canada. We have all these different provinces that are not really truly interconnected. So we are selling power north-south, not east-west. So that's another major challenge, right? Nevertheless, this is going to be a major concern. So it's mostly oil-based. Then we have Saskatchewan, which is similar to, not as significant, but very close to what is happening in Alberta. Oil-based, petroleum-based, fossil fuel-based electricity. So another major challenge for them. Although the demand is not as high as what they have in Alberta. So we also have to be mindful of that context, right? How much demand, how much generation is required. And then you have Manitoba, which again is 97% hydro. So no problem with 2030 net zero. Then we have Quebec, which also is 95% hydro. Okay? And here what is happening is there's significant, wind is now about 4% of the energy. They are increasing the participation of wind by basically introducing wind into the system, so they don't have to use hydro resources and build new dams. So that's a big motivation in the context of Quebec. Not the lack of water, but not having to build new dams, which has environmental impacts. Then we have the Maritimes and Newfoundland and Labrador, which changed significantly. For example, in the case of Newfoundland and Labrador, 94% is hydro. But then if you look at, for example, New Brunswick, then you have a significant part of natural gas and oil, fossil fuel type of generation. The same you have in PI, and well, PI is really, that's an interesting example because it's wind, mostly wind. But it's a very small system. So it's feasible in the context of the interconnections they have with the rest with the mainland, right? So that allows them to have a wind power based system. Okay? And then you have Nova Scotia, which is basically, as you can see, fossil fuel based as well. So there are major challenges, although these are relatively small systems. The Ontario system is a very particular, unique system in the context of Canada. Like Alberta and Saskatchewan are based all, we are basically nuclear. Okay? And as you can see here, nuclear and hydro are basically 85%, which is, from the point of view of emissions, is basically clean. Okay? Now, there are issues with nuclear waste and how you manage that, but from the point of view of emissions, it's basically a clean system. So it's 85%. And notice the role of, even though gas generation is 25% of the capacity, the actual natural gas emissions are about 3%. So it's relatively low. It's only for peak power. Okay? So it's a fairly clean system. Now, how are we going to maintain this system, which is basically based on nuclear, is a major challenge, right? It's a concern on how you're going to do that. Now, with all these promises, and I want to highlight the fact that of all these promises that I have described, only to have a competitive market. The rest are basically vertically integrated, which we have a major utility that is running the whole thing. Okay? In the case of Ontario and Alberta, they are unique because they have a competitive type of market. Semi-competitive, it's really a hybrid market, but because we have fixed tariffs, we don't have locational marginal prices and all of those details that make a true market, if you will, although that's changing in Ontario. So that's another challenge that has to be faced because, for example, that means that part of the market is not owned by the province, is owned by private entities, right? So that's a different challenge that some of the provinces have to face in all of these transitions. And then we have all the issue Canadian remote communities, which is another electrical system that one has to deal with. Okay, all the issue of how we're going to serve all of these relatively small communities, which go from fractions of a megawatt to 200 megawatts, which are not that small. Okay, and how are these being served? Okay, most of these are based on diesel generation. So that's a major challenge, right? How are we going to clean this system? Because it's not just that you clean the provincial systems, you also have to clean these multiple systems. But however, the interesting thing is that there's a lot of resources, wind and solar resources. Solar is actually a part of the solution, even though we're in the north. For example, if you look at southern Canada, if you will, there's significant solar resources that can be used, even in Ontario, okay? Which are not negligible. And even in some areas in the far north, you can still use solar, and there are examples of that. Wind is another factor that has to be considered in all of this, especially in the areas close to the coast, okay? Close to water. So this is the situation in Canada, in the remote communities, which I mentioned. This is about 170 communities based on diesel, mostly based on diesel. Okay, we're talking about not a very large population. Okay, about 100,000 people, a bit less, and the multiple communities in which you have good wind speed averages that allow this integration of renewables. Okay, and then we have the problem of generating fuel, which is not only the emissions. Particularly in the Arctic, it's a major problem. Soot is a major problem because these diesel generators emit this black dust, settles on the ground, and melts the ice a lot faster. Okay, so that's one challenge in the Arctic. The other problem that it has to be faced is the cost. You have to transport this diesel from the south to the north, and there are no roads. It's very hard to get to these locations, so it's very costly. Okay? That's the other challenge. It's not only the emissions, but also the cost. So a significant cost involved. So how do you clean? If you're going to clean the system, you have to clean these systems as well. So that's another challenge that we have to face in Canada. Now, let me get into the details of Ontario. Ontario has basically a backbone grid of 500 kilovolts and 230 kilovolts, which transmit power all through the province. Okay? But in the north, because this is just part of Canada, this is just part of Ontario, all the northern part is basically remote communities, which are now being integrated through a 230 kV transmission line to the Ontario system. Most of these communities, through this new line that is being built by ISO, are going to be part of our system. So that's going to be addressed somewhat. I think that at the end of the day, just a few communities are going to be basically based on diesel. The rest are going to be integrated into the system. So that's a solution. This is a line that was talked for decades. Eventually, in the last 10 years, basically, it's become a reality. So soon that be integrated, those communities be integrated into all of this. And when I'm talking about these communities you see here, here's the line. All of these are going to be integrated into the system. There's a line going through this area. There are going to be a few, well, these are going to be difficult. This area, these further north are not going to be part of this system. So for the most part, Ontario is going to address the issue of diesel generation that way. It's a $10 billion line, by the way. It's not a cheap solution. Okay? So it's a significant cost. But that's not the option for many other communities very far in the north. By the way, the motivation for building this line is not only that they're going to, in which, by the way, indigenous communities or the local communities are involved in this effort. It's also the issue of they want to, give access to electricity for mining reasons in the upper north. And this is the generation up to 2015. So as I said, mostly nuclear. These are these three stations. One is being phased out, which are now is being delayed by a year or two. And then this Darlington, which is being transformed into, or they want to transform into small nuclear reactors or modular reactors. And then this Bruce, which is our main source of electricity in Ontario. We have a peak load of about 25 to 30, well, depends on the year, gigawatts. That one produced 5 of them. So it's quite significant, as you can see, a fifth at least. Okay? And this was just refurbished. Part of the reasons why we're paying so much on electricity is because of that. It has nothing to do with wind, or very little to do with wind and solar, which was the argument that the government was using, conservative government keeps using. Okay? It's actually due to that refurbishing of that big plant. That costs billions. And that's what we pay for the most part. Even gas doesn't play a major role in this, because as you can see, it's only 3% of the energy. So we increases our cost, but really we're paying for that. And not for the feed-in tariffs and any of that. It's very small in a factor of the cost. Anyway, this is the situation in energy, as already mentioned. It's interesting, if you look at this, you see the transition from coal. By the way, this is not energy, okay? This is a capacity. Because when you look at energy, as you can see, changes, right? Even though 25% is, or 28% of the capacity is gas, the actual use is very small, okay? Or relatively small. It's actually comparable to, it's actually less than wind. Although as of 2018, some of these pending stations, et cetera, were not built or were being built, were basically shut down, basically. The contracts were canceled, which cost the government of Ontario about something like $100 million. Okay? But anyway, that's the situation. So when you look at this, you see the transition from basically a fairly dirty system to a very clean system, okay? From the point of view of emissions. So we have to be careful with that. Now, when you look at this other picture, it's interesting to see how things change from we used to basically import power. We have become big exporters of power. Actually, we are one of the, I think in Canada, we are the province that exports most power to the US, which sounds kind of weird because you think, well, we used to buy all this power, now we're selling it. The problem is that we're selling it at basically discount prices, negative prices. Why? Because it's mostly nuclear that you cannot control, and it's at night, you cannot turn off those generators, so you just give it away. You actually pay people to use it. Okay? So that's the situation of our system. So that's the other problem, challenge with nuclear. That's what they're looking at, as more modular reactors to try to make that more flexible. Okay? Nuclear stations cannot be turned off, cannot be regulated. They're basically based and stay there because otherwise they become unstable and can become a major problem. Okay? Now, this is the transition from a basically provincial run electrical system to a market base, which was by the conservative government in 1998. But this act created this restructured electricity system. Okay? So it created the Ontario Energy Board, okay, which is a market regulator basically. Then created the OPA, which now has disappeared. Now it's been integrated into the ISO, which is a more normal way of handling this, which was basically, the OPA was created, the reason for creating the OPA by the Liberal government later on was because there was not enough generation being built in Canada, in Ontario. And why we're not building in Ontario? Because of these reasons. Politically, we are very risky. Because once you change the government, things can really flip, okay? So when we were talking about generator, people investing in generation, no, we don't want to invest. We can make money, but it's very risky because in 5 years, things might change, which is what happened with wind, right? Wind and solar. Okay? The contracts were canceled, and then all of a sudden, one day you're making money, the next day, right? You have a lawsuit in your hands. So that's one of the reasons why this was created, to buy electricity and to basically buy generation or incentivize the generation. So that's all the 20-year contracts for gas generation, 20-year contracts for wind and solar, which actually were a minor part of it. Okay? And then Hydro One basically was split in three parts. Ontario Hydro Company was split into OPG, the generation company, Hydro One, the transmission company, which, by the way, is the largest distribution company in Ontario, and the ISO, which is the market operator. And if you look at the distribution companies, the local distribution companies, if you look at this map, most of the area is covered by Hydro One, which is one entity. Okay? And then we have small utilities which are now being coalescing. Electric is an example of it. This also happened here. It's happening here in our region as well. They are merging, right, to try to get a economies of scale. Getting bigger allows them to make more money, make more significant profits. Okay. Most of it, by the way, is served by Hydro One, which is our rural or small town distribution company, besides being a transmission company, which is now private. Okay? Now, we have the market open. This is an interesting history of the market in Ontario because opening in May 2002, and at that point, the prices increased from 3 cents a kilowatt hour to 6 cents a kilowatt hour, and the government promised that the prices they're going to reduce. It actually went up. And what happens is that after a few months, by December, okay, from May to December, which was happening because there was an election, etc., actually now we created this fictitious price for electricity, okay, which was financed by OPG, by the way, which was making a lot of money, yeah, to use that money to finance these sort of cross subsidies of electricity. So it was everything was political, basically. It was not very much has to do with technical issues. It has very much political issues. Okay? And interestingly enough, by October, they lost the election. Okay? A good part because of the mess of the electricity market. Okay? And if you remember, the Liberals also lost the election because a good part of the energy issues, right? Cost of electricity, what happened with Hydro One, privatization, and all of those aspects. Now, in the process, the Liberals created this system, the smart meter system, which we have been pioneers in that area. Actually, the smart meters are becoming old, and they are being replaced for more sophisticated meters. The smart meters were never smart, by the way. The only objective of the smart meters was just to be able to measure electricity by hour. Nothing else. We could not communicate really with them or exercise any control. It was mostly for purpose of measuring, getting how much you are consuming at what time. And that created this electricity, time of use electricity costs, okay? Which are basically having, as you can see here, have been increasing steadily from when it was set up to what it is now, okay? And I think by 2020, I think now it's 12 cents, if I remember correctly, so it keeps increasing. We are one of the most expensive jurisdictions in North America, by the way, in terms of electricity. Okay? It's still very cheap. We were talking to our colleagues visiting from Germany, students visiting from Germany, they tell us now the electricity cost for us is an average about 11 cents per kilowatt hour when you factor all of this in. The way we consume electricity, for them now used to be 30 cents, then went back to 40, now they're paying 70 cents per kilowatt hour. Okay? 7 times what we are paying. Why? Because of all these issues with Ukraine, gas, Russia, etc. Okay? And this is what happens with electricity. The electricity price is very interesting to see how the peaks were at the start of the market because there was not enough generation, to this situation in which now you have negative prices because we have too much generation. Okay? So things have flipped. Now, one interesting part of all of this is that the demand charges, which is how much you pay for your peak demand, not only the energy, have basically increased significantly. Now the industry folks have this problem, that energy is relatively cheap for them. The cost of capacity, your peak power is basically 10, well, not 10, but 5, 6 times what they pay for energy. Okay? So that's another challenge. And this is associated with the fact that gas is costly and is used for this peak power. Okay? Base power is supplied by nuclear. Now, a capacity market was created. In fact, Professor Bhattacharya, which is a colleague in the department, basically created the tools for implementing this market, which is a seasonal, basically, offer of demand. How much you're willing to pay for your demand, right? To try to address this issue of the cost of demand cost. Now, what is the future going to look like, okay? What is it being planned, okay? Now, in 2017, the Liberal government, the ISO under the Liberal government, created this plan, okay? A 20-year plan, focus on managing customer electricity costs, demand side management, demand response, okay? Because of the problems with the generation capacity, which was nuclear, gas, and coal, so the phase out. The market renewal, which is basically creating the capacity market now, which has been implemented, and created these locational marginal prices, which is a penalty for you pay more if you consume the electricity in points in which the transmission is expensive. Okay? If it's easy to get to the electricity there, it will be cheaper. If it's difficult to get the electricity there, or there are congestion lines, you will pay more. This is what happens in most markets in the States. So that's been implemented or been discussed. The integration of new technologies, especially energy storage and distributed energy resources, that was the plan. The LDC performance as well, increase energy conservation and efficiency, that's another big drive, all of these, demand response programs, and increasing renewable energy sources. If you look at the new plan that is coming out, it's all of this, but this. Renewable energy sources is not part of the discussion for why? Because that was the debate the conservative government had when they basically were poo-pooing wind and solar, basically. They say, no, wind and solar, no, that's part of the problem, not the solution. So when you look at the new plan being developed, it's basically the same up to here, and there's no major reference to renewable energy sources. Why? Politics, right? It should be part of the solution, but it's not. So this is what basically conservative government is doing. So if you look at this, it's basically the same thing as what it was in 2017. By the way, they basically filed this, tabled it, filed it, put it away, forgot about it, and then they are creating a new plan. Okay? And this is important. There's no mention, direct mention, in this plan, there's no direct mention of renewable energy sources. Why? Because they have this issue that I already mentioned, right? The canceling of all these generation contracts for wind and solar. Okay? Now, the energy transformation network in which I was involved first Yatin, then myself, is the issue of how to introduce the distributed energy resources in the market. Okay? So part of this discussion is that to solve this problem of electrical generation is start generating electricity locally. Okay? And how are you going to do that? So first, basically, the network identified, there's a report, it's a blueprint, it's a guide that it was presented to the Ministry of Energy and the ISO, and it's basically is how you're going to introduce distributed energy resources, what kind of markets, what is the role of the ISO, what is the role of the local distribution companies, what is the role of the Ontario Energy Board for the integration of distributed energy resources to basically facilitate and create a market for it. Okay? And these are the recommendations, which is basically distribution system operators or distribution companies basically are going to manage that, okay, locally as opposed to the centrally controlled by the system operator. So that's the main bottom line of all of this. So LDCs were very interested in all of this, and they will take the role of distribution system operators. Okay. Now, what is the situation of EVs? How we doing in the electric vehicle market on the electric vehicle issue? Now, if you look at these numbers that are extracted from this reference here, you can see that if you look at all of these, you can see, first of all, that the penetration of electric vehicles is very, very small compared to other places. In Ontario, in particular, it's smaller than anywhere else. If you look at British Columbia and Quebec, they have an extra incentive that we used to have. They have an extra, the government gives you $5,000, the federal government, an incentive. And then the provincial government, in case of Quebec and BC, gives you an additional $3,000 or so. So by the time you collect these two, the price of your car is the same or less than buying a gas vehicle. Okay? So it's a big incentive. Okay? But in spite of all of that, the penetrations, as you can see here, the Quebec is higher. Okay? British Columbia, 8.4, 6.8. If you look at Ontario, I don't know whether I have it here anywhere, but in general, it's relatively small. Okay? However, the intention is that this keeps increasing. Okay? There are more offerings, more vehicles, more brands, more types that are coming to the market continuously. Okay? Now, what is the problem with that? The problem with that from the electrical point of view is that, okay, where is that energy going to come from? Okay? Because if you look at this, the peak power of these vehicles is between 6 kilowatts to 10 kilowatts. For example, a Tesla model or a CORA are about 7 kilowatts peak power. That about doubles the size. Houses, residential homes here are designed to have a peak power of about 10 kilowatts. Okay? Because you don't use all the electricity at the same time, the actual effective peak power is between 6 and 7 kilowatts in our homes, which is basically, if you install an electric vehicle, you put an electric vehicle, you double it. So how are you going to handle this? Well, one has to be conscious that most commutes are about 50 kilometers, 50 or less kilometers of commute. Okay? So we're talking about 80% of the population commuting at that level. So there are a few people, like myself, that commute longer than that. Okay? Okay, so the problem, when you look at this, then you look, oh, okay, well, level 1 and 2 is enough. You don't need level 3 for commuting. Okay? Long trips, you do need level 3, but for commuting, you don't. Okay? So interestingly enough, when you put if you want to put level 1 is just connected to your 20 amp, 50 amp, well, 20 amp outlet, right? So just connect it there and then you charge the car. That's what I do. That's all I need. Okay? Even when I don't charge here, if I do it overnight, it's enough to charge my vehicle for that period of time. Now, the problem is that if you put a level 2, then it's basically twice as much as the load. You need now 30. You need to go up to 30, 40, 50 amp capacity, depending on the vehicle you have. Well, let's say 30 amps. That's enough. That gets you about 6 kilowatts, 6, 7 kilowatts. So when you do that, you need to double, because another circuit, you already have a 100 amp panel, right? 100 amp panel gives you the electricity you require. But you put one of these, now you need to increase the size of by standards, double the size of your panel. That's about $3,000. Plus the installation of adding this 40 amp connection. So major challenge. So my approach has been, okay, well, let's actually use, you already have 30 amp circuits in the dryer. Your range is 50 amps. So you already have these circuits in your system, in your house. So if you double purpose this with a transfer switch, when you are not using the dryer, you can charge the vehicle if you really need to. Okay? So that will basically eliminate the demand of doubling the capacity of the transformer in your house. Because there are issues with people buying Teslas. There are issues already, particularly in Toronto, in which they are not allowing to put level 2 chargers in the system. Dedicated chargers. Why? Because you have reached the capacity of the distribution transformer. So when people go and ask the utility, well, I want to install a level 2 charger, say, you pay for the transformer. Okay? Otherwise, no. So how are we going to address this issue is with smart charging, with this type of approaches, right? Being smart about how we're going to be charging these vehicles. And I think it's manageable. Nevertheless, if you look at charging the vehicle at peak hours, not overnight, you're basically going to have to double the size of the demand. So basically, you are thinking about doubling the size of them. So that's more, double the generation, double the transmission, et cetera, et cetera. Okay? So it's a major challenge. Okay? Now, incentives. These are the incentives that I was mentioning. Okay? These were these are the incentives that were there until 2018, which have been basically eliminated. What is the mission?
Just wanted to tell you there's about 5 minutes.
Okay. Yeah, I'm almost done. So what are the issues of emissions? Emissions in the case of Canada, they have not increased, but they have not come down really. So we have a major challenge from the perspective of a net zero future, right? So how we address this? Okay? So there's a plan. There's first a 2030 emission reduction plan, which is basically incentives to reduce demand, right? For example, I'm installing a solar panel in my house. And I'm getting $5,000 from the federal government, an incentive. The same if I install a heat pump, for example. I would get, well, it's a maximum of $5,000. If I install both, I only get $5,000. Okay? So the intention is all of these are basically the incentives and the targets. Okay? So for example, they want to reduce oil and gas emissions to 75%. Okay? Good luck with that in Alberta. So I don't see that happening really anytime soon. So that's going to be a major challenge because 2030 is 7 years. It's just around the corner. So that's a major challenge, right? And all these investments, which are significantly, right? We're talking about billions of dollars invested into incentives or plans to reduce the emissions. Okay? The other part of it is it's an $8 billion net zero accelerator and the net zero challenge. Okay? Which is basically challenging business to reduce the emissions to zero by 2050. And then there's the hydrogen plan, which is the other aspect of it. Because part of the solution is not only electrical, but also hydrogen. Why? Because there are many processes that depend on hydrogen, which are cannot be transformed into electrical systems. Okay? And how are you going to produce that hydrogen to be able to supply that? And it's also part of the storage solution. Okay? So the challenges are what the economics of all of this is. The recommendation is basically try to look at solutions for these problems. So to conclude my presentation, just about in time. Now, would it be possible, the first question, would it be possible by 2035 to eliminate emissions in the Canadian grids, which is the target of the government? Most of them, yes, but it's going to be very difficult in Alberta and Saskatchewan. Okay? Very doubtful. Would it be ready for 2050 expected demand? Well, it's going to require huge investments, right? We're talking about 300+ billions, okay, of dollars, like what happened with the Inflation Reduction Act of the U.S., which is basically all about emissions. Okay? And the markets by themselves are going to do it. Okay? You need some incentives, significant incentives. The other issue is the need for developing distributed energy resources and the integration locally, which creates microgrids. Okay? Now, Would the transition to electric vehicles is going to take place? How fast? By 2050, I think that personal vehicles and fleets are likely to become all electrical. Okay? Because by 2035, basically it's a commitment to not sell gas vehicles. So it's going to happen by force. Okay? Now, the problem is that what are you going to do with heavy and long-haul transportation? And that's where hydrogen plays a role. Okay? Hydrogen is going to be a solution for this problem. However, we got to keep in mind that the electric vehicle state of the art is changing, right? With the current state of the art is feasible. With what is going to happen with, for example, solid-state batteries, this is going to be game changers to make it more longer range, less need for load, for energy, et cetera, better batteries. Okay? Costs, I don't think are going to come down anytime soon with new technologies, but eventually, once they become part of, that's the only vehicles are sold, the economies of scale are going to kick in. Okay? Now, how about thermal systems? Well, it's likely by 2050 because all these issue of the state of the metal heat pumps, I mean, these are well-known technologies. So it's just an issue of integrating them and making it part of getting rid of your furnaces and replacing them by basically electrical systems. Okay? How about hydrogen? Okay? Well, they are indispensable for decarbonizing the industrial sector. There's no way around it. So we need to figure out a way of generating hydrogen. And the other thing is the decarbonization, very important decarbonization of heavy and long-haul transportation. And finally, I mean, that's my final message, is that we can really not wait any longer. We have to do something now. Okay? And this is on a personal level now. Okay? So first of all, go and get an electric vehicle. In terms of cost, they are very similar. I mean, there are charges everywhere. I mean, there's no argument of that it's too expensive anymore. The costs are comparable to what you do when you go and buy, with the incentives when you buy a gas vehicle. First thing, install a solar panel. Okay? Make an effort. That's what I'm doing. Replace your furnace with a heat pump. Now, this is getting personal now. It's not only, the government is the problem of the government. No, it's also our problem, individual problem. Okay? It will not be cheap because there's a cost of it. Electric vehicles maybe not, but solar panels is costing me an arm and a leg, even with the $5,000 that the government is giving. Replacing the heat furnace, the furnace with a heat pump is, $10,000, something like that. So it's expensive. More than that, there you go. However, we really make a commitment, right? We need to invest. The way I see it is an investment. My wife says, why are we installing a solar panel? Who is paying for that? What are we going to save? Well, I don't think I'm going to save a lot in electricity, right? So, but I'm making, in my point of view, I'm making an investment in the future, right? Not only for me, but for my grandkids. Now I have 3, so for the future, right? So we're thinking of the future. And my final message is that we have to stop dilly-dallying because we are just keep talking about it, we don't do anything. So we need to start walking the walk, talking the talk, right? So we actually have to be doing. Okay, guys, that's all I had. Do you have any questions?